All right, so how did that happen? How does, basically two loops run when only one thing is happening? So with this kind of thing, a recursion is a method that calls itself. So let's actually trace this one to see where those numbers came from. Okay. So the way that this works, when I call 5, 2, mystery 5, 2, I'm just going to call it M for simplicity's sake. It comes here, and it puts a 5 here, a 2 here, 5 here, a 2 here. And it checks the condition. Is 5 greater than 2? Yes. So it comes in and does this line. So this line has its output. So I'm just going to put the output down here. 5 space 2. Then it does this. This one calls itself. So it technically doesn't get to the next line. It doesn't get to here until after it's finished and after this condition fails. Okay? So that's the basic idea. This condition here allows this recursion to end. Otherwise, it will never end and your computer will crash, even with a simple problem like this. Okay, so when it calls 5, 2, it comes down here, does the output, and then it calls n minus 1. So 5 minus 1 is 4. K stayed 2. So when it calls that, this is now a new call. So it comes up here, this is now 4. This is 2. 4, 2. When it comes in here, it outputs 4, 2. Then it calls itself again. But itself now, n minus 1, this is now 4 minus 1, that's 3. K is still the same. Yes. So now I'm calling M the mystery 3, 2. So this is 3, this is 2, this is still good. So it comes in here, outputs 3, 2. Then it calls itself, where n is 3. So 3, so it's going to call mystery 2, 2. So erasing this, 2, 2. Is 2 greater than 2? No. So this is how we reach the base case. This is why it says it's over here. It does not even enter this little area. It just says it's over. Okay. Now the problem with recursion is, problem or good thing, depending on how you think of recursion, is that I have done this much of each of these methods. Well, this one I did the whole thing. This one's over. But this one, I only went up to here for this method. I did not finish it out. So in recursion, it like stacks up what it didn't finish, and then it finishes it in the backwards order. So I finished 2, 2, so now I have to finish 3, 2. So it's done here, it's done up to here, and now it has to go to here. So when I get to there, it's going to say 3, 2, because that's the one I'm calling. Then so now this one's done. Now it's going to do this one. So it backs it up. Now it's going to do this. And then it's going to do this. And now it's completed each of the methods. So now it's done. So that's why that's the output for this one. With recursion, it stacks up. Now I don't technically stack mine up because I like to go down. I don't know, it's just the way. But it stacks these up, and whatever it doesn't finish, it has to finish. So it kind of keeps hold of it. And because of this, recursion is very, I'm just erasing it so I can move this down. Recursion is very much a memory eater. So you can't have too much done in recursion. It has to be basically like a search, a short search. Okay, with this one here, we're doing some math. So we want to call mystery 5, 5. So I'm going to call M. You know what, with this one, I can do the work over here because there's only one thing we're going to do here. So you know I had to output this in order for this to work. So when I call mystery 5, 5, it's going to put a 5 here and a 5 here. Okay, notice this n minus 1 is always working this n towards the base case, which is 0. So once it gets to 0, then recursion is over and it backs it up and finishes it out. So that's what the base case is all about. That's why this recursion always has to be in an if statement. So we look at this. Is 5 greater than 0? Yes. So it's going to return. So 5, 5 is actually equal to k is 5 plus whatever mystery 2 is. Whatever, just m, doesn't matter. Mystery 2 is, which is 5 minus 1, which is 4, 5. So it's going to call that one. But I don't know what that is. This is a recursive call. You may remember this stuff from sequence and series and trig and or algebra 2 or whatever you were in. So I called it with this. This is my second call. Okay. Now, to figure out what m mystery, I'm just going to call it m, mystery 4, 5 is, okay, I have to run mystery 4, 5. So now this all gets changed. Now this is a 4, 5. So I look at it, 4 is greater than 0. This is a 5, so 4 minus 1. So this is 5 plus the mystery of 3, 5. And it continues to go through this until n, this number here, is 0, and then it will end. Okay, it always has to be greater than 0 for the recursion to continue. So the mystery, this is my third call. So I have to figure out what that is before I can continue. So it's 5k plus mystery of 2, 5. So now this is a 2. So it's still greater than 0, so this is going to still continue. So that was my fourth call. So now I have to figure out what that is. So this just keeps continuing, and you figure out the fifth call is 1, 5. And we have to figure out what that is. It's 5 plus 0, 5. So now I'm finally at the base case. So at this point, probably should have made it a little shorter, but at this point, n is 0. So if n is greater than 0, we're going to do this, but it's not now, so now we're going to go to 2. So there is no recursive call in the sixth call. So the sixth call is the last one. And I figured out that 0, 6 is 2. So mystery 0, 6 is 2. So now I'm going to change my color. Hopefully you can tell I did. So this is 2. So now I just figured it out. Now I can back it all up and finish the whole thing. So this is 2. 5 plus 2 is 7. Now that's what M1 is. M1, 5. So this is 7. So 5 plus 7 is 12. So as you can see how backing it up, makes this work. Once I reach my base case, it's now over. And I just has to unwind and finish each of the methods. So 12 plus 5 is 17. This is 17. 17 plus 5 is 22. And 22 plus 5 is 27. So that is what this is. So it would return 27 for mystery or Mis2 5, 5. Okay, finally this last one is a little more complex, I guess you could say, because it has 2 calls in it. So it has calling mystery 3 here and here in one call, so it's recursing twice. Now this is where it's most useful if you're actually going to create code, for using recursion. I would avoid it in my world, but recursion can be used, and it's used a lot in binary searches. Any search where there's a tree, where you're branching out and you're searching things. And okay, so like, files in a computer program. You have to back it up when you're finished to output it and stuff like that. So if I want to call mystery 3, this kind of thing, we kind of have to do this slightly differently, the tracing of it. So mystery 5, n is 5, 5 is greater than 0. What it does is it does this one first. It doesn't do what comes second. Okay, it does that later. But what you have to realize is every call to mystery is going to have a branch of 2 because it's called twice. So each branch, each leaf is going to have 2 branches. I don't know if that's the greatest analogy right there, but that's how it works. So the first one is this call, and that's the one we're going to focus on first until we get to our end. So mystery N2, so it's going to call mystery 5 minus 2, which is 3. All right, so nothing is actually happening yet. So then I'm going to call mystery 3. So that would be mystery 1. And then keep going. The condition has to be greater than 0. So 1 here, this is 1, is still greater than 0. So I have one more call to do here. And when I subtract 2, it's going to be mystery 2. Negative 1. That ended it. So at this point, when I call mystery negative 1 here, so when this is negative 1 isn't greater than 0, so it won't enter here. It's going to return the 1. So that means this guy is 1. Okay, so I have an answer for that one. But remember, each one of these, I have to add a second part to it. So once it's got the 1, it's going to come back up here and do the second call. Okay, so mystery n minus 1, that would be mystery 1 minus 1, that's 0. 0, this one's fun, right? If you do 0 here, 0 is not greater than 0, so this one will also return 1. Right, so 1 plus 1, so now this guy here is 2. So I figured out what M1 is. So anytime I see M1, I know it's going to be 2. That might be useful later so that I don't have to retrace this 17 times. Okay, so this one's done, but now I have to figure out what it adds to for M3. So for M3, this would be mystery 3 minus 1, which is 2. Okay, so I don't know what that is yet. I thought I did, but no, M1 is 2. So mystery 2, we don't know what that is, so we have to call mystery 2. So this starts it back at the beginning. So when I call mystery 2, 2 is greater than 0, so I'm calling the first branch. So remember, each one of these is going to have 2 branches every time I call it, unless it's the base case like these two here. So M2 would be M0, but we do know M0 is 1. That was this one. Come back up to the 2 and do the second. What am I adding 1 to? Well, I'm adding 1 to mystery n minus 1, which is 1. Oh, I know what that is. Mystery 1 is 2. So M1 is 2, so I'm going to add 2 to it. It's 2 plus 1, so this is 2, this is 1. 2 plus 1 is 3. So these two added together make this guy 5. Okay? That's fun, right? Totally get it, Ms. Barris. Okay, so we add. We have to now figure out what we add when we're doing M5. So M5 has to finish out. It has to do this mystery call for M5 now. So that mystery call for M5 is M4. And M4 needs to also have 2 branches off of it. So we have to go back. So M4 here, just you kind of have to do each one like it's a brand new day. Okay, mystery 4 would be mystery 4 minus 2, which would be mystery 2. Okay, plus mystery 3. Okay, I know the reason that I just did that instead of going down and back up again is because I know what mystery 2 is. Mystery 2 is right here. Mystery 2 is 3, and I know mystery 3 here. This whole set of branches that I do here, this whole mess right here, allowed me to find M3. So I don't have to do this all again because I know what it is. M3 is 5. So 5 plus 3 is 8, and 8 plus 5 is 12. So this is showing you how to do a branching. Obviously, this kind of thing would not be used to add these up like this, but you have to be able to trace it so you begin to understand how recursion goes down, you know, and then winds itself back up to finish off any method or any work that's there. I know it was a little bit, but